it flies from South Dakota to Iran and comes back. The B-1B Lancer, variable sweep wings, 4 afterburning turbofan engines, a combat radius that covers the entire Persian Gulf from Ellsworth Air Force Base without a single refueling stop, and returns. Internal weapons bays carrying 75,000 pounds of precision munitions. JASSM air cruise missiles with a 1,000-kilometer standoff range. Blue 109 penetrating warheads designed for hardened underground targets. On March 2, 2026, a package of B-1Bs flew from South Dakota to a target set. The Iranian military had been hardening for 30 years. A dispersed underground ballistic missile network buried beneath granite and concrete across multiple sites in western Iran. The complex U.S. planners called Missile City. 75,000 pounds of precision munitions. 29 separate tunnel complexes. One night. In the weeks following March 2nd, Iranian ballistic missile launches declined by 86%. The regime had spent 3 decades and an estimated $23 billion building a network designed to survive an American strike. It was underground, dispersed, hardened to specific penetration specifications. By every metric Iran's military planners had used to model the threat, survivable. Then the wrong aircraft showed up. Iranian state television broadcast a video no Western analyst expected Iran to release publicly. 2 IRGC generals riding a golf cart through a tunnel complex, passing row after row of ballistic missiles on mobile launchers, Shahab 3s, Imad variants, Sejil medium-range systems, stored underground in a facility the video was designed to show could not be destroyed. The message was explicit. Iran has moved its strategic missile force underground, and underground is where it will survive whatever the United States or Israel attempts. The video was propaganda. It was also accurate. Since the Iran-Iraq War, when Iraqi airstrikes on surface installations demonstrated how quickly exposed assets could be destroyed, Iran had been developing underground military infrastructure. After watching U.S. air power eliminate Iraqi surface military architecture in 43 days during the Gulf War, IRGC engineers began systematic tunnel construction that accelerated through the 2000s. By 2020, the network stretched over 3,000 kilometers. Missile storage, command centers, manufacturing nodes, maintenance complexes. The design assumption was precise. The United States, constrained by political pressure, basing logistics, and penetration limits, could not deliver enough firepower to enough dispersed sites simultaneously to collapse the network in a single strike. That assumption held for 20 years. Then it didn't. Here is the question that 29 collapsed tunnel complexes forces you to ask. The B-2 Spirit costs $2.1 billion per airframe. It carries the GBU-57 massive ordnance penetrator, a 13,600-kilogram bomb specifically designed to destroy hardened underground facilities. The GBU-57 is the only conventional weapon capable of threatening targets buried more than 60 meters below ground. The B-2 is the only aircraft that can carry it. The B-2 can carry 2 GBU-57s per sortie. Missile City has 29 tunnel complexes. Penetrating the deepest bunker and collapsing the entire network are 2 different missions. Iran built its doctrine around the first problem. The United States had to solve the second. And it solved it with an aircraft that the Air Force had nearly retired. Enemy Decoded doesn't cover the strike. It decodes why the B-2 wasn't the answer, and why the aircraft that was had its nuclear mission removed by a peace treaty. If that's the analysis layer you came for, stay with us. Iran did not build Missile City against the B-1B. It built it against the B-2. IRGC tunnel engineers knew the GBU-57's published specifications: 60+ meters of penetration through reinforced concrete, less through granite. They knew the B-2's payload limit: 2 GBU-57s per sortie. They built to those specifications. Primary command facilities hardened to depths the GBU-57 could not reliably reach, and secondary storage nodes distributed across 29 sites. Too many for any B-2 strike package to collapse simultaneously before Iran dispersed its mobile launchers to tertiary positions. Iran's defense was not a single hardened facility. It was a cost ratio inversion, forcing the United States to spend more time, more sorties, and more political capital than the objective justified. The calculation failed because it solved for the wrong aircraft. 3 obvious platform choices. 3 separate disqualifications. The B-2 fails on magazine depth. 2 GBU-57s per sortie against 29 distributed sites requires sequential strike packages over days, long enough for Iran to disperse mobile launchers beyond the modeled target set. The B-2 solves the penetration problem. It does not solve the volume problem. Against Missile City, volume was the primary problem. The B-52 fails on survivability. Even with Iranian air defenses degraded by weeks of preceding strikes, the B-52H carries a radar cross-section incompatible with the threat environment that existed on March 2nd. A platform that cannot survive ingress cannot deliver its payload. The F-35 fails on payload. Its internal bays are configured for precision strike munitions optimized for stealth compatibility, not the penetrating warhead mass required against hardened tunnel entrances. It can mark and suppress. It cannot collapse 29 complexes in a single package. The B-1B is different on all 3 variables. Its radar cross-section, while not stealth class, is substantially lower than the B-52 and compatible with the March 2 threat environment. Its 75,000-pound payload allows enough JASSMER and BLU-109 combinations to address multiple aim points per sortie, and its range from Ellsworth eliminates the basing constraint entirely. It was not the obvious choice. It was the only platform that didn't fail. The B-1B Lancer was designed to end the world, not metaphorically, literally. Its original mission was nuclear strike penetration, low altitude, supersonic, through Soviet air defenses, delivering thermonuclear weapons to targets inside the USSR. The variable sweep wings, the terrain-following radar, the internal bays, all of it built for that mission. In 1994, the United States removed all nuclear capability from the B-1B fleet, not because the aircraft failed, because a treaty required it. New START and its predecessor agreements mandated the B-1B's denuclearization as part of the Strategic Arms Reduction Framework between the United States and Russia. The aircraft was stripped of its nuclear weapons delivery circuitry and its original strategic identity. Overnight, the most capable low-altitude penetrating bomber in the arsenal became a conventional strike platform in search of a mission. That is the reframe. The nuclear removal was not a demotion. It was an accidental optimization. A nuclear-accountable B-1B required rigid command hierarchy, launch authorization chains, and operational constraints that limited responsiveness. The conventionally configured aircraft retains all the penetration performance, all the range, all the payload capacity, without any of that overhead. The mission flexibility that makes it uniquely suited to a distributed, time-sensitive target network like Missile City was a byproduct of denuclearization, not a design choice. The unexpected hero is the new START Treaty, an arms control agreement between Washington and Moscow, signed in Prague in 2010, designed to count warheads and reduce delivery vehicles. Produced as an unintended consequence, the conventional strike architecture that collapsed Iran's underground missile network 16 years later. The diplomats in Prague were not thinking about Iranian tunnel complexes. A peace agreement built the weapon. A war proved it worked. The B-1B did not operate alone on March 2nd. It was the culminating instrument of a sequenced strike architecture that had been running for weeks. F-35s suppressed Iranian air defenses and provided real-time targeting data in the hours before the B-1B package arrived, feeding updated tunnel entrance coordinates into B-1B targeting systems during the ingress leg. The crews were not working from pre-planned coordinates alone. They were working from a live picture generated by the aircraft flying ahead of them. B-2S had struck the deepest hardened command nodes in the weeks prior, the facilities where depth and penetration radius were the only variables that mattered. By March 2nd, the command architecture coordinating Missile City's dispersed launchers had already been degraded. The B-1B's mission was not to destroy a functioning system. It was to collapse a system already partially decapitated. Volume and distribution were the remaining problem. 75,000 pounds was the answer. The platform was not a substitute for the B-2 or the F-35. It was the final instrument in a sequence. And the sequence was what made the 86% reduction possible. Iran wargamed American strike options against Missile City for years. The conclusions were coherent, well-sourced, and wrong in three ways. The penetration assumption. Iran's tunnel specifications were calibrated against the GBU-57, the only conventional weapon capable of threatening its deepest facilities. Iran knew the penetration radius. It knew the B-2's payload limit. It built to survive what the B-2 could deliver. That calculation was correct for the deepest sites. It was irrelevant for 29 distributed tunnel entrances that a 75,000-pound conventional payload collapsed in a single night. Iran solved for penetration depth. The B-1B brought volume. Iran solved for the wrong variable. The basing assumption. Iranian doctrine assumed a strike package of sufficient scale would require regional basing, carriers in the Gulf, air bases in Saudi Arabia, pre-positioned assets Iranian intelligence could track. A B-1B flying from Ellsworth removes that ceiling entirely. No regional basing, no host nation overflight permission, no pre-positioned signature to anticipate. Iran built its model around an adversary who needed to be close. The B-1B made proximity irrelevant. The platform assessment. Iran had tracked the B-1B as a secondary conventional asset since 1994, useful for large raids but not configured for the precision targeting hardened underground facilities required. That assessment was accurate in 2003. The integration of JASSM-ER onto the B-1B's internal weapon stations had transformed its precision ceiling by 2026. Iran's models were built on the 2003 capability profile. 3 decades of tunnel construction, 3 miscalculations, 86%. It originated an assessment circulated by U.S. Central Command in the days following March 2nd, attributed to battle damage assessment teams working from post-strike imagery and signals intelligence, subsequently cited in reporting by 3 major Western outlets. Enemy Decoded has not seen the underlying assessment. No independent non-U.S. verification has been published. The distinction between damaged and destroyed is unresolved. Collapsed tunnel entrances are not permanently neutralized complexes. Iran has demonstrated in previous conflicts a significant capacity for rapid underground repair and reconstitution. Whether the 86% reduction in missile launches represents permanent degradation or temporary suppression Pending repair remains an open question. The B-1B's role as the primary strike instrument is sourced from DoD statements and flight tracking, consistent with Ellsworth departure patterns. The precise munitions mix has not been officially confirmed. Enemy Decoded works from what is available. The strategic logic is accessible. The operational details remain classified. The question Iran spent 30 years making unanswerable was simple. How do you build a missile network the United States cannot destroy? Its answer was underground, distributed, and deep. 29 sites dispersed across geography. Granite overburden measured against the GBU-57's penetration radius to the meter. The answer that arrived on March 2nd was not a new penetrating weapon or a forward-based strike package. It was an aircraft that a Cold War nuclear doctrine built, that a peace treaty accidentally optimized, and that flew further than Iran's targeting doctrine assumed any conventional platform could fly without regional support. The B-1B did not defeat Missile City because it was the most advanced platform in the American arsenal. It defeated Missile City because it was the wrong platform. Wrong by Iran's calculations, wrong by the threat models, wrong by the doctrine that said penetration depth was the only variable that mattered. It brought volume to a target set defended against precision. It brought range to a model built on proximity constraints. It brought 75,000 pounds to 29 tunnel entrances from a base Iran's planners had not included in their strike radius models. Iran built Missile City against the B-2. The B-1B showed up instead. A peace agreement built the weapon. A war proved it worked. And the aircraft is already back in South Dakota. Enemy Decoded explains what others won't.